Okay, so if you recall from class on Wednesday, we're talking about systems of equations, which just means we're gonna have two equations, two variables. And we looked at three different methods in order to solve them. One is by substitution, one is by elimination, and one was called cross graphing or crossing graphs, which just means we put it in the calculator and look for the intersection. Okay. Now, from there, what we're going to do today is the equations will not be given. We will be given information and we have to write the two equations and then solve using one of the methods that we looked at on Wednesday. Okay, so in reading your information and coming up with an equation, don't just start pulling numbers out and cross your fingers and hope you get it right. Okay, put some thought and intent in it. And I'm going to try to give you some hints as we go. All right. So this first one, we have a bag that contains 44 coins consisting of nickels and dimes. The total value is $3.50. How many nickels and how many dimes are in the bag? Okay, so we know we're talking about nickels and dimes. So I'm going to call in my nickels. And D is my dimes. So there's my two variables. Now I need to come up with two equations. Okay. When you're dealing with a problem like this, here is my hint. All right. Your first equation is going to deal with quantity, which means the number of points. Only quantity, not their value. Just, hey, I have 10 coins. Hey, I have 3 nickels. I have this many dimes. It's just talks about quantity. All right, then the second equation is going to be an equation that deals with value. That would be, oh, a nickel's worth 5 cents. Oh, a dime's worth 10 cents. So one of them is just quantity only. The other equation is value, and you do not cross those two. Okay. All right. So what do we know about the quantity of our nickels and dimes? There's 44. All right. So we know this deals with quantity. All right, does this mean 44 nickels? Does it mean 44 dimes? What does this mean? What does the 44 mean? Total, right? So we know that however many nickels that I have, plus however many dimes that I know I have a total of 44 coins. That could be 1 and 43. It could be 40 and 4. That's what we don't know. But I do know the total of my coins is 44 coins. Okay. All right. So that's my first equation. So now what we're going to do is create an equation based upon value. Well, what is the value of a nickel? Nickel. 5 cents. So 5 cents nickel. That way, if I know I have 1 nickel, I have 5 cents of value in my nickels. If I had 2 nickels, 5 cents times 2 means I have 10 cents. Okay. Plus the value of my dime is 10 cents. Now, what is the value of monetarily that's in the bag? There's your value. Now, here's what I'm saying is that you never cross equation these. You're not going to have n plus d equals 350, because then you're dealing with quantity over here and value over here. Nor are you gonna do 0.05 N plus 0.10 D equals 44, because you're dealing with value here, and then you'd be dealing with quantity here. Okay, all right, so now we have two equations, two variables. So now we need to solve for those variables. This is where we looked at on Wednesday by substitution, by elimination, or by crossing graphs. So I asked you at the end of Wednesday, and I'll ask you again, we can do any of the three. Which of the three would somebody like to do this by? Okay, I was gonna say Wednesday, y'all told them, several of you that voiced your opinion that you like substitution best. Okay, so let's solve this by substitution. Okay, if you recall, my hint for substitution was choose the equation that at least one of the variables has a coefficient of 1. Do I have either of my equations that has that? Okay, my quantity or my value in? Quantity. So what I'm going to do is I'm going to take this equation and I am going to solve for, now if you'll notice, both have a coefficient of 1. So it doesn't matter, solve for N or solve for D, it wouldn't matter. I'm going to go ahead and just solve for N. Okay. All right, so I'm going to do that here. Bless you. So we have N plus D equals 44. And if I solve this for N, I need to move the D. How do I do that? I'm going to subtract it. So now I had N, or I'm left with N equals 44 minus D. Okay, so now we take this and substitute it in for the N here. Because N is the same thing as 44 minus D, so in place of this N, I'm going to put 44 minus D because this is equivalent to N. Now, I still have plus 0.10 D equals $3.50. Now, the goal of that is that I now have an equation where I'm going to solve for one letter. So now all that's left is the variable D, so I can solve this. Okay. We did something similar to this on Wednesday, so don't start moving stuff. Be sure both sides of your equations is completely simplified. So if you'll look on the left, the first thing that we're going to do is we're going to distribute that 0.05 through. So 0.05 times 44. So let me know what that gives you. 2.2. Okay, so that's 2.2. Now, at this point, if you put 2.2 or 2.20 because of money, either is fine because we are solving the equation and those represent the same. All right, minus 0.05 D plus 0.10 D equals 350. All right. Don't start moving any of the terms of the D. They're on the same side. So you are going to combine those like terms. So what you're going to do is, and you can do this in your calculator, negative 0.05 plus 0.10. We still have the 2.2. What are you left with? 0.05? Somebody say that? And it's positive. So I'm left with positive 0.05 D equals $3.50. And that makes sense because this is positive 10 cents, negative 5 cents, 10 cents minus 5 cents is positive 5 cents. Okay. All right. Now the left side is simplified. So now we're going to start isolating that D. So the first thing that I'm going to do is move the 2.2. It's positive. So we're going to subtract it on the other side. I have 0.05 D equals, what's 3.5 minus 2.2? 1.3. And again, if you put 1.30, it means the same thing. Now we're gonna divide by both sides by 0.05. So D, which don't forget, that's the number of dimes because it's no longer associated with the value. What's 1.3 divided by 0.05?
26.
Okay, so this tells us we have 26 dimes. And it asks for how many nickels and dimes. So we found the number of dimes. Well, it shouldn't be hard then to find the nickels because we know we have a total of what? We know we have a total of 44. So I'm going to take 44 minus 26 dimes. And what are we left with?
18.
And 26 plus 18 is 44. And then if I did 0.05 times, we have 18 of those. Plus 0.10, we have 26 dimes. It should give me $3.50. And sure enough, it does. Okay. All right. Okay. On this next equation, we're talking about the cost. So it says two competing rental car companies charge different rates. ABC Rental charges $29 per day and 6 cents for each mile. XYZ charges $35 per day and 5 cents for each mile. If you rent the car for only 1 day, how many miles must be driven for the costs to be the same? Okay, so I know I've got C is costs. And what else is my variable, would you say? What else are we looking at here? Look at the question. What's the question asking me? Miles. Okay, so let's look at ABC Rental. This should ring a bell to something we've done in the past. We talked about total costs. So let's look at ABC Rental, charging $29 per day and 6 cents for each mile driven. Does anybody recall what this 29 would be called? Not your initial value. Think back further. What? Fixed costs. Remember when we talked about fixed costs and variable costs? Okay, so this goes back. We have to think back to what we've done before, and we know that cost is equal to fixed cost, which is like your initial value, but I was looking for fixed costs. And we would add that to your variable cost times your variable. Kind of remember doing that? Okay, so ABC Rental, we're looking for the cost, which is C. You told me the fixed cost is $29. So how would I write the rest of that equation to show variable cost times variable? What fluctuates? What is my variable cost with ABC Rental? 6 cents per mile. So I'm going to add that I'm also charged 6 cents per mile. So now we're going to do the same thing with XYZ Rental. Again, we're looking for cost. What was the fixed cost for XYZ? Now it's 35. And what's the variable cost? And that's 0.05, y'all, not 0.5. That's 50 cents. Okay, so there's our two equations. And that goes back to something that we have done in the past. Okay. So what is, the last question asked me how many dimes and how many nickels. But this is telling, what's the other bit of information that they're telling us? It's in the very last, well, it's in the question. What are they telling us about our equations? They're asking how many miles for one day when what is true? When the costs are the same. Well, if the costs are the same, then the costs are, what's the word we use with equations when we say the same? Equal. This tells me then you're going to be paying the same amount, so your two equations are equal, right? So what they're saying is we want to look at this when the cost from the ABC rental is the same as the cost from the XYZ. So I'm going to put the cost in for my ABC, 29 plus 0.06 miles equals the cost of the XYZ, 35 plus 0.05 M. So I have an equation where I have one variable now. Now, this one's different than the other one. The last equation we did, the variable was already on one side. Now we have a variable on either side, so we need to move one of them. So how could I move this term over here? I'm going to subtract it. It's being added, so I'm going to subtract it. So I'm left with 29, and if I have 6 cents and I take away 5 cents, I should be left with positive 1 cent. So it's 0.01 M. And then on the right side, we're left with that 35. All right, so we're solving for M. So now I need to get rid of this standalone number or constant. How do we move the 29? So I'm going to subtract it. So I have 0.01 M equals, that's 6, and divide by 0.01, both sides. What does that give you? And 600 what? Miles. Now, let me go back and see what's being asked. If you rent the car for only one day, how many miles must be driven for the cost to be the same? So that's all it asked, so I could stop. Okay. If I was asked, so if asked, how much it costs, because that could happen. So if you're asked how much it costs, how would I do that? How could I find the cost? Does it matter which equation I plug it into? No, because remember, we were figuring out when they were the same. So I'm just going to plug it into the first one. So if I wanted to know the cost, I could do 29 plus 0.06 times 600 miles. So how much is that going to cost me? $65. Just in case that was asked. Then if you went to your calculator and did 35 plus 5 cents times 600, you're going to get 65 as well. So again, this question only asks for this. So if that were on the test, you could stop, but you might be asked that also. So I want to be sure and look at that. Okay. Okay. You have $90 to spend on refreshments for a party. Large bags of chips cost $5 and sodas cost 50 cents. Okay, just for purposes of variables, I'm gonna call sodas pops. And I'll tell you why I changed that here in a minute. Okay, what are we given? Or would you say we're given some value of something? The value of the chips, the value of things? Okay. You need to buy exactly 5 times as many sodas as bag of chips. How many bags of chips and how many sodas can you buy? Okay, so this is a little bit similar to the nickels and dimes. And so I'm going to show you how it's similar, and then I'm going to show you where it's different. Okay, so I'm going to call C chips. And then pop. The reason S sodas, S looks too much, but I don't like using the variable S in an equation. All right, that's why I changed it, no other reason. Okay, so we're gonna deal with, again, a quantity equation. And we're gonna deal with a value equation. Now, when you look up in the problem and you see those numbers, the numbers that you see that are given, do you mainly see value numbers or quantity numbers? Value. Okay, so let's start with that. Let's start with the value. Okay, what's the value of chips? $5. So that would be $5 for every bag of chips. And if you put 5.00, that's perfectly fine. And we're going to add that to the value of our pop, which, what is that valued at? How much? 50 cents. And that's times pop. So it says chips cost $5, pop costs 50 cents. That's where those numbers come from. All right. Do we know the total value that was spent? $90. All right. Now, here's where this problem is different than the nickel and dime. If they said, we have a total of 100 items, you would do C plus P equals 100, but that's not what we have. Okay. All right. So I need to think through this. Think of these as our variables. If I looked at it in an ordered pair, it would look like this. So just to wrap my head around, I'm going to do a T chart dealing with chips and with pop. Because what I do know on the quantity is that you need to buy exactly 5 times as many pop as bags of chips. So if I have 1 bag of chips, how many pops do I need? 5. Right? Because I need 5 times as many. All right. If I have 2 bags of chip, how many pops do I need? 10. So 3 bags of chips would be 15 pops, right? Okay, so everybody see those ordered pairs. Okay, so I've got to take this information and say, okay, if I'm going to write an equation, I know they have to be equal. So let's look at this pop where we have the number 5 here. What could I do to this 1 to now make them equal? If I took 1 and did what with it? Add, subtract, multiply, or divide something to get it equal to the 5. Multiply by 5, right? 1 times 5 is 5. All right. Here, if I needed this 2 to be 10, what would I do? Multiply by 5, right? If I needed this 3 to be 15, what would I do? Multiply by 5. So what you're doing is you're taking the number of chips that you have and you're multiplying it times 5 to get it to equal to how many pops that you need. So this is your second equation. 5C equals P. for every bag of chip, 1 bag of chips, 5 times 1 is 5 pops are needed. That's what you did in your head to get to the 5. So we're just writing that out in equation form. So you may have to ponder on that one. I get it, it's a little bit more difficult to grasp. Okay, so now I have my 2 equations, substitution, elimination, or graphing. I think there's one that it's already set up and good to go. Okay, why substitution? Is there an equation that's already solved for a single variable? Yeah. So if P is equal to 5C, then can't I just take this and substitute it in for this? So substitution is the one that jumps out for sure on this one. So we'd have 5C plus 0.50, and we're going to substitute in place of P, we're going to put 5C equals 90. All right, so we have 5C plus, is that 250 or 2.5? Which would be $2.50. Okay, all right. Now we're going to solve for C. Do I move anything? No, I just combine those like terms, right? These are like terms. So 5 plus 250 is 7.5C equals 90. Divide both sides by 7.5. So how many bags of chips? So we need 12 bags of chips. And we know then our pop, we need 5 times that, right? Isn't that what it said? So we need 5 times the number of bags of chips. So we need 60 pop, but POS, that's not good. Soda. Did you catch that? Heard a little chuckle. Okay. So again, up here, what we had to do is we had to take however many bags of chips that we have, which we call C, and we had to multiply that times 5 to get it equal to pop. Okay, let's do the extra practice. We'll call it a day, and this assignment will be due on Monday. Okay. Look on Blackboard at announcements. I'll look again, but it's always there. So we shouldn't, because we didn't finish anything. 1, 3, 4, I think it's due Wednesday, but it's always on Blackboard. Okay. So this first one says solve the systems of equations. So we've been doing that today, but every one of them we have done by substitution. And you could choose that on this one. I wouldn't though. Why not? Do any of the coefficient, are any of the coefficients 1? Which means then if I solve this for X, I'm eventually going to be dividing by 4, which means I can get into some icky, ugly fractions. Same thing here, I would eventually divide by 3. So I wouldn't use substitution because none of my coefficients are 1. Okay, so that leaves us with either elimination or the graphing one. Okay, I'm going to go ahead and do elimination because we have not done that today. So who recalls what's important about elimination? What's our ultimate goal? We need a positive and a negative, even a little bit more than that. The coefficients of either your X or the Y have to be
opposites. So they do need opposite signs, but the numbers have to be the same as well, right? Okay, so I wanna look. When I look at my X's, they're both positive. Neither have the same number. They're not both 4s or both 5s. So that means if I were to eliminate the X's, I'm gonna have to multiply both equations times something. Such as if I wanted to get it to be 20, I would have to multiply the first equation by 5 and the second equation by -4. So you're gonna have to be multiplying both equations by something, which is fine. But you might run into more opportunity to make a simple error. Okay, so then I look at my Y's. Now they're both negative, which I don't want them both negative, but they both have the number 3, right? So they already have the same number. I just need one of them for their sign to change. So of the two things I'm looking for, this satisfies one of them. So I'm going to eliminate the Y's. The first equation, I'm not going to do anything to it, but rewrite it. So that would be 4x minus 3y equals 6. Now, the second equation, I need this 3 to be positive 3. Well, -3 times what is positive 3? -1. So what I'm going to do is multiply this whole equation by -1. Not just the y term, it affects every term. So this 5x will become -5x. This -3y will become +3y. And this -3 will become +3. And then what do we do with these two equations? Add them. So 4x plus -5x is -1x. Opposites, when you add them together, gives you what? 0, which was our goal, equals 6. So I have -1x equals 6. I don't want -1, so I divide both sides by -1, and I get x equals negative. Yeah, I can't add today, can I? Sorry. -9. Thank you for catching that. Now, remember, our ultimate goal is to find an ordered pair that satisfies both equations algebraically. And we have found the x, so is that the first or the second number? First. So we have found this to be -9. So now we need to find y when x is equal to -9. So choose one of them. It doesn't matter which one. Do you have a preference? First or second one? First one. Oh, I heard somebody say second. I heard second first, so I'll go with that one. Again, it doesn't matter. So 5 times x, but we know x is -9, minus 3y equals -3. 5 times -9 is -45 minus 3y equals -3. We're solving for y. If I want to move -45, I add 45 to the other side. So -3y equals, and again, if use your calculator if you're not good with your positive and negative numbers, but this would be 42. And we're going to divide by -3. So we get y equals negative something. So what that means is if I went to that Desmos that I showed you on Wednesday and I put these two equations in, they will intersect at this ordered pair. Okay. All right. One evening, 1,500 concert tickets were sold
for the Fairmont Summer Jazz Festival. Ticket costs $25 for covered pavilion seats and $15 for lawn seats. Total receipts were 28,500. How many of each type of ticket were sold? Okay, this is like the nickels and the dimes. But instead, we have P for pavilion seats, and we have L for lawn seats. I did capital because a lowercase l looks like a 1. Okay, so that means I'm going to create an equation that deals with quantity. And then a second equation that is going to put the value to everything. Okay, so in the information given, what number goes with quantity? $25 is money, that's value. Oh, okay, if I misheard, sorry. And is, what do they tell us? What is this? Total tickets? So it's just saying, okay, my pavilion tickets plus my lawn tickets is my total of 1,500 tickets. All right, let's put a value on pavilion. How much were the pavilion tickets? So that would be 25p plus what's the value of the lawn seats? 15. So 15L, and what was the total value? All right, so then you need to solve. You have one of 3 methods. Which method you want to use? Substitution. Okay, so if we're going to use substitution, we will solve this one. Obviously, I'm not going to come down here because these have a coefficient of 1. You want to solve for P or L? P. All right, so I'm going to solve for P. I'll come down here and do it. If I want P by itself, subtract L. So we're going to take this that is equivalent to P and put it in here. So we would have 25 times 1,500 minus L plus 15L equals 28,500. Because again, this is the same thing as P. All right. Distribute first. We're going to get a big number. What's 25 times 1,500?
37,500.
27,000?
37.
37. 37.5. Is that what you said? Okay, thank you. Minus 25 times L. It's 25L plus 15L equals 28.5. I have like terms right here and they're already on the same side. So just combine those like terms. So 37,500 negative 25 plus 15 should be negative 10L equals 28,500. So to solve for L, I need to move 37.5 to the other side. It's positive, so I'm going to subtract it. So I get negative 10L equals, and this is negative what? How much? 5 by negative 10. And that makes sense because you wouldn't, your final number is going to be positive. 900. And this is lawn seats. Would it have made sense to get a final negative answer?
Are you gonna sell negative 900 seats? No. So now I need to know pavilion. Well, we know the total is what? 1,500, so just do 1,500 minus 900. 600 pavilion seats. Okay.